Hello guys, welcome to Under the Hood, a series where we uncover how Linux concepts translate directly into containers, Kubernetes, and modern DevOps tooling. You may have heard the advice, learn Linux before learning Kubernetes, right? But here we will see how they connect. We will show and we will see how they connect. That's exactly what this series will do. So who this series is for? So beginners curious about containers, DevOps engineers who use Kubernetes, SREs and platform engineers wanting deep internals, anyone debugging production systems. So if you have ever run Kubernetes, Docker, or ECS and have asked, why does this behave this way? This series will finally give you the answers from the Linux point of view. So in this series, each episode builds logically. No random concepts. It's a structured path from Linux, containers, Kubernetes, and production behavior. So before learning isolation mechanisms like namespaces or resource limit, we need one core understanding. A container is not a virtual machine. It's just a Linux process with boundaries. And today we'll prove that live. Many people imagine containers as tiny independent operating systems, like mini virtual machines. But that's not true. A container is just a regular Linux process running on the host kernel, but with boundaries and restrictions. So why does it feel separate? Because Linux gives it namespaces, cgroups, and a separate file system view, making it look isolated, but the kernel shared. So to prove container is just a process, we will prove it through a live demo. So the requirements are Docker installed or containerd plus nodectl. I'll write assuming Docker. You can adjust as per your requirement or whatever you have installed, containerd or nodectl. So let's go ahead. So we'll start with a clean host system. On our Linux system, we'll just see whether Nginx process is there. Let's go ahead doing that. So we don't have any Nginx process running. This is just the Nginx that we are grepping. So if I want to exclude the Nginx grep from matching itself, let's do that and let's prove that. So there is no Nginx process running. Now next we'll try to run a Docker container of Nginx. Let's go ahead and do that. Now we run a standard Nginx container. We use a standard Docker run command to start the Nginx container and we will name it as web server. So let's go ahead and do that. So we'll do a Docker run, name it as web server and Nginx. So we have a Docker container running. Here it is. So now what we will do is we'll check the process of Nginx on the host, which was not showing before. Let's see whether it shows up now. It is showing up, as you can see, right? So the host OS sees it plainly. The Linux host doesn't see a container, it sees a standard Nginx process that is there. As you can see, here is the process ID, and it can see as a plain Nginx process. We saw it is just a plain process, but are its files still isolated? The host can see the process, but the file system is the core container isolation. So now let's create a file inside the container to see if we can find it from the host. So we'll just do a docker exec, the web server, and we'll just do a touch and name it as my new bar. Let's do that. So we'll do docker exec web server and we'll just touch with a my new bar. Okay, so that's done. So let's see if we can also see the file from the host, Linux host. So the /proc file system is a special virtual file system in Linux. It contains real-life files, but runtime system information. It contains a directory for every single process running on the system named after process ID. So since containers are just processes, we can use the slash proc to look inside. So let's go and see if we can see the Nginx process ID that we just saw. So let's grab the process ID and just do a sudo ls proc paste and root. So yeah, we can see the file that we just added using the exec command, right? Here, you can see it over here. So the file created inside the container is fully accessible from the host, just like any other file in any other processes directory. So it is clear the container is not a box. When you run Docker run, you are not starting a lightweight VM. You are starting a standard Linux process. This process is visible and manageable by host OS. So containers are possible because Linux evolved to isolate processes. In next episode, we'll go deeper into Linux namespaces, the true engine behind container isolation. So now that you have understood that containers are just processes, the next logical step is learning how Linux isolates those processes so they appear independent. So now that we have established the foundation, containers exist because Linux isolate processes. In the next episode, we will explore PID, network, mount, user, IPC, hostname, and how each one maps directly into Kubernetes pods. We will be learning about namespaces. So stay tuned.